So what we're going to do in today's video is we're going to introduce ourselves to the product rule. And the product rule essentially tells us that the derivative with respect to x of f of x times g of x, so the product of two functions, is going to be equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. So it's going to be f prime of x times g of x over here plus f of x times g prime of x over here. And so essentially, this also can be extended to however many functions you have, and you just have to kind of notice the pattern. So if you're taking the product of three functions, then it would be the derivative of the first times the other two functions, plus the first function times the derivative of the second times the third, and then as you can imagine, you just continue on. So this can be extended to however many functions you're taking, but we're just going to focus on two right now as we introduce this concept. And so essentially, what we're going to do over here is we're going to take the derivative of these functions, and it may be helpful to consider each separate function and their derivatives before we actually apply the product rule. So we're taking the derivative with respect to x of the product of these two functions. So we have 3x squared plus 7x times 12 times the square root of x minus 1. And what we could do is we could expand it if you would like, but what we're going to do is we're going to use the product rule because it may get a little bit messy if we're sitting down expanding all of these terms. And so let's go ahead and do that. So if we consider this to be our f of x right over here, and this to be our g of x, then what would f prime of x be? So as you recall from the power rule, we would just go ahead and look at the exponent of our different terms, and we would take that down as our coefficient. So 2 times 3 is 6, and then we would take x to the 2 minus 1, right? We decrement the exponent. 2 minus 1 is just 1, so this is just going to be 6x. And then with 7x, we remember that whenever we have a linear function, 7x to the 1, this 1 right over here would come down as our coefficient, so we get 7 times 1. And then we get x to the 1 minus 1. But 1 minus 1 is just 0, right? So this is just the same thing as 7x to the 0. And we know that x to the 0th power is always going to be equal to 1. And so then we can just keep this as 6x plus 7. And then with respect to g of x, let's take a look at g prime of x. If you remember how we take the derivative of the square root function, I'm hoping by now you might have gotten a little bit more familiar with it. But essentially, what we did is we would take this square root of x and rewrite it as x to the 1/2, and then just apply the power rule so that we'll get that the derivative with respect to x of x to the 1/2 is just 1/2 times 1 over the square root of x. I don't know why I wrote it that way, but yeah, or another way to write it is just 1 over 2 square root of x. And so if we multiply that by 12, so we get 12 over 2 square root of x, then the 12 and the 2 over here will simplify into 6 over the square root of x. So this is just 12 times the derivative of that. So we will get 6 over the square root of x. And then right over here, remember that the derivative of a constant is always equal to 0, so we just take that out immediately, so this would cancel out. And so now what we can go ahead and do is we can actually apply the product rule. We can put our different pieces together and use the product rule. So let's look what we have to do. We have to take the derivative of the first function times the second function. So that's going to be 6x plus 7 times the second function over here, which is going to be 12 square root of x minus 1. And then we're going to go ahead and add that to the first function, which is going to be 3x squared plus 7x, and then we're going to multiply that by the derivative of the second function, which is going to be 6 over the square root of x. And then we could go ahead and simplify this, but I'm just going to leave it like that. So this could be our final answer right over here. Again, you can expand it out and simplify, but the whole point is just to kind of get you familiarized with how we would even use the power or the product rule. And so the next thing that we're going to go ahead and do, so as you can see, it's pretty easy to apply, actually. You just need to find the individual components, and you'll get very used to it, and you can even start doing it in your head as time progresses. So over here, we're taking the product of these two functions. We have 1 over x squared minus 2x to the 8th. Let's, consider this to be our f of x. And then we have the cubed root of x plus x to the 4th. Let this be our g of x. And so the derivative of the product of these two functions, we can go ahead and first of all consider the derivative of f of x, so that will be f prime of x. 1 over x squared is the same thing as, x to the negative 2, so then with its derivative, we're going to take this negative 2 down and then decrement the exponents, we will get negative 2 x to the negative 3, right, because that's just negative 2 minus 1. And we can rewrite that as 1 over x to the third, but I'm just going to leave it like this for the time being. And then negative 2x to the 8th, we can just take this 8th down, or this 8 down as our coefficient, so then we'll get 8 times negative 2, which is negative 16. And then we have x to the 8 minus 1, which is 7. With respect to g of x over here, g prime of x, we're just going to go ahead and consider the derivative of these two terms. And so the cubed root of x, we know that we can rewrite that as x to the 1 over 3. And then when we take the derivative, we would just take this 1/3 down as our coefficient and then decrement the exponent by 1. So we get 1/3 times x to the 1/3 minus 1, which is another way to rewrite 1 is just 3/3, right? So 1/3 minus 3/3, which is negative 2/3. Again, I'm not going to, sit down and simplify this. We can just keep it in this form for the time being. And then finally, x to the 4th. Again, we would just take this 4 down as our coefficient and decrement the exponent by 1. So we would get plus 4x to the 4 minus 1, which is just 3. And then finally, we can go ahead and put this into the product rule. So the derivative of the first function, we'll get negative 2x to the negative 3 minus 16x to the 7th. And then we're going to multiply that by the first function, as you would see over here. So we're going to multiply that by what we determined to be g of x, which is going to be the cubed root of x plus x to the 4th. And then we're going to go ahead and add that to the first function, which is 1 over x squared minus 2x to the 8th times the derivative of the second function. So that's going to be 1 over 3x to the negative 2 over 3 plus 4x to the third. Again, you can go ahead and expand this out and simplify as you'd like, but again, we're just going to leave it in this form because, this who could bother to simplify this, to be honest. And so essentially the point of this video is just to introduce you to the notion of the product rule and how we can apply it to different functions over here. And what we're going to do is my plan is to introduce all of these different derivative rules so that we can start taking the derivatives of more advanced functions and seeing where they come from. So derivatives of exponential, logarithmic, and trigonometric functions.